Hi, this is Adam Griggs, Science Manager for River Network. I'd like to welcome you to this segment on accessing flow data and flow statistics, a part of River Network's science module on water security and environmental flows. This video will show you how to access data and calculate flow statistics for your watershed by using the new USGS Water Census Data Resources Portal. Here again is Dave Blodgett, Project Coordinator for the Data Resources Portal. I'd like to thank you for viewing this segment and encourage you to explore the other recordings and resources available in the science module. So stay tuned for other upcoming webinars and resources, and of course invite you to join us at our next annual River Rally. And now Dave Blodgett from the US Geological Survey.
Great, thanks Adam, and thanks everybody for tuning into this module. I'm going to be demonstrating several tools to access Streamflow data from the National Water Information System and some modeled data for the Southeast U.S. And then I'll share some statistical tools to interpret that data for ecological flow studies and analyses. So the web page we're going to be looking at today is at cida.usgs.gov/NWC, stands for the Center for Integrated Data Analytics, the U.S. Geological Survey, and the National Water Census is NWC. But I'll show you how to navigate there through Google. So we'll switch over to a browser here, and the easiest way to find what I'm going to be presenting is just to Google for National Water Census. And so the first link that comes up is the National Water Census homepage. So if we go there, this is everything about the National Water Census, and the thing we're going to be focusing in on today is our ecological water research topic. If you follow through the ecological water link, you can get an overview of what the National Water Census is doing in regard to ecological water. And the points that I want to focus on today are the development of baseline or minimally impaired or unmanaged hydrographs. So these are modeled streamflow based on observed streamflow in minimally impaired or unmanaged watersheds. We also have a goal to be able to produce streamflow classifications for particular species or assemblages of species. And this all kind of leads into something that you can see a presentation by Brian Richter from the Nature Conservancy on, which is this ecological limits of hydrologic alteration, or this, more broadly speaking, ecological effects of hydrologic alteration studies. So this is a set of studies that are ongoing within the National Water Census and around the ecological flows community. We have studies ongoing in multiple regions in the country and some higher level methods studies for the entire country. And the resources that I'm going to share next are kind of the work in progress that we're putting together as public data resources and tools to help serve these sorts of studies across the country. So from here, I'm going to navigate into the National Water Census Data Portal, which is the portal that we use to help people discover data resources being made available by the USGS and the National Water Census. The portion of the portal that we're going to look at today is the Streamflow Statistics workflow or section of the portal. And in another video and other videos that we're putting together for this set of science modules, you'll be able to see how to use the water budget workflow as well as the aquatic biology, and we will also briefly share the data discovery. Today we're going to look into streamflow statistics. When we come to this page, the basic workflow or how you would use the page is summarized at the top, and some documentation about what's presented here is also in the header of the page. I encourage you to follow some of these links and read up on exactly what's available through the interface. But I'll go ahead and walk into actually one of the stream gauges that we looked at in a previous module looking at water budget data. That stream gauge is near Demopolis. I can search for Demopolis, and here we see Demopolis, Alabama. You can zoom into Demopolis, and we zoomed into the Southeast U.S. And what we see on the map now is the blue dots are stream gauges. You can see in the lower right here, stream gauges, and the gray polygons are watersheds. And so we have streamflow available for both stream gauges and modeled streamflow for watersheds. We'll start by looking at a stream gauge. So we'll go into the stream gauge just downstream of Demopolis, Alabama. We can see this is the Tombigbee River at Demopolis. Has a nice long period of record from 1928 to 2016. And if you want to see more information about the site, there's a link to NWIS Web, where you can go off and see the actual inventory of data available for this site, additional information. And the other thing I'll point out right now is at the top of the page here, there's a link to a GitHub page. GitHub is a code management community, and this is a set of our Streamflow statistics calculation functions that are used in the National Water Census Data Portal. I'll be showing how to use these tools against NWIS inside this web page next. So we've chosen a National Water Information System NWIS stream gauge. We can look at a plot of the stream flow from that gauge. So here we've got the entire period of record, the daily stream flow record for that stream gauge. We can grab onto the handles below the plot and zoom in for a particular time period and pan across to see what the hydrograph looked like. The thinking with this interface is that you could look at two very different time periods and compare kind of what the hydrographs look like if the nature of flow has changed. You can look at that visually. But then we can also look at these time periods using these statistical tools at the bottom of the page. So we'll choose a 10-year period, 1929 to 1939, and let's take a recent 10-year period, say 2005 to 2015. And there's a number of statistics that can be generated here. The first one available is called the 7 Fundamental Daily Stream Flow Statistics. This is some recent research out of the US Geological Survey. The paper that they were released under is called an objective and parsimonious approach for classifying natural flow regimes at a continental scale. So this is all about how to classify stream flow hydrographs according to some very basic statistical characteristics. So we'll calculate these 7 fundamental daily stream flow statistics for these two time periods. And there are also a number of groupings of statistics from magnitude, frequency, duration, timing, and rate of change of flow. Each of these is a number of statistics that fits into a group. These are documented in a paper that was actually released along with some software some years ago called the Hydrological Integrity Assessment Process software. These are a number of common statistics that are used for ecological flow studies and are fully documented behind these papers. So for now, let's just look at the 7 fundamental daily stream flow statistics. If I calculate statistics on both of these, what the server is currently doing is going to the National Water Information System, downloading a daily stream flow record for 1929 to 1939, 2005, and to 2015, and running them through our statistical functions that are available for you to download and run on your local computer from this eFlowStats GitHub package. So looks like these have finished, and so now we get a table saying for this site number, for a date range, 1928, 1939, 2004, 2015. And note that these are calculated on a water year basis. These are October to the end of September. We get back the mean, the coefficient of variation, the skewness, the kurtosis. So these are the first few moments of the time series, as well as some other statistics for amplitude and phase. And we can look at how these have changed from one time period to another. So more information on how these might be applied is available from the publications linked on this page and elsewhere in the ecological flow statistics literature. So from here, so we have these kinds of capabilities available for NWIS stream gauges, and from here, many people are going to be interested in seeing stream flow on river reaches that we've not observed stream flow directly as part of the National Water Information System. So the stream flow statistics interface that we're very much in the middle of building out is going to include modeled stream flow as well for many watersheds across the country. And we started doing this in the Southeast U.S. So let's just zoom back to Demopolis home base here. And we can see the stream gauge we were looking at was there, and all of the gray polygon watersheds represent incremental 12-digit hydrologic unit code watersheds for which we've estimated streamflow. The methods used to estimate streamflow are described in a paper linked on the page, which I'd encourage you to read prior to using these streamflow estimates in any real application. But we can take a look at them. So let's just choose a watershed nearby the stream gauge we were looking at. So we'll zoom in here, and if we click on a watershed, you'll get back the hydrologic unit code, the name of that watershed, what its drainage area is, and a polygon that represents the total upstream area. If I go back one, I just want to show the comparison of back into Demopolis here. So I selected this polygon here that's close to a confluence, and what I got back is a much larger upstream area. So this is the upstream contributing area that goes to the confluence incremental watershed that I chose. And this is something you see in the previous water budget video that we presented. A 12-digit hydrologic unit code watershed can have a local incremental watershed or a total accumulated upstream area. And this is the total accumulated upstream area because we're looking at streamflow. So just like with NWIS, at the bottom of the page here, we can look at a streamflow plot. In this case, the modeled streamflow is only available from 1981 to 2010. So we could look at an early period of record and a late period of record. We could choose a time period. We can choose one of these sets of statistics and calculate. So now for an ungauged area, not as long of a time range as we're going to have available from some NWIS stream gauges, but for a reasonable period of record, we can do the same kind of comparisons from one time period to another to look for potential changes in the streamflow record in these statistics. So as I've said, this is a work in progress. We're hoping to build out more streamflow estimates. We're definitely hoping to build out more of these statistical methods, as well as to bring in ecological flow classifications for these watersheds to help people understand what sorts of ecological conditions should be expected and how existing conditions might compare across the landscape. So look forward to that, and as always, we would very much welcome your feedback and input. My email, dblodgett@usgs.gov, is at the bottom of these web pages. Please don't hesitate to contact me with any comments or questions. And thanks for watching. I'll pass it back to you, Adam.
Thanks, Dave. It's great to see those excellent flow resources becoming available. To all of you who joined us, thank you for watching this segment, and we hope you're excited about accessing the data and tools on the Water Census Data Resources portal. Also, please make sure to check out the other resources that are part of the science module. And if you're looking into developing water budgets or investigating environmental flows, please feel free to contact us at River Network, either Catherine Bear or myself, and there are the web addresses there for you. So thanks a lot.